Hello everyone, I am Mrs. K. Vanitha, Assistant Professor working in the Department of ECE at K.S. Rangasamy College of Technology. We are going to see the lecture on distance vector routing in the course Computer Networks under the module Network Layer. So routers, before going inside the distance vector routing, we need to know what are all routers and how routing is performed. A router is a three-layer device, namely physical data link and network layer, that routes the packets based on the logical addresses. Router normally connects LANs and WANs in the internet, and it has a routing table that is used for making decisions about the route. Routing tables are normally dynamic and are updated based on the protocol. Routing, we are going to see the unicast routing. There are two types of routing, unicast and multicast routing. Unicast routing is one-to-one. That is, one device wants to make a communication with every other device, every other node. An internet is subdivided into autonomous systems. An autonomous system is a group of networks and routers under the authority of single administration. Routing inside the autonomous system is otherwise called as intra-domain routing. Routing between the autonomous systems is otherwise called as inter-domain routing. There are number of protocols in the routing, intra-domain routing, inter-domain routing. Distance vector routing and link state routing are coming under intra-domain routing, and inter-domain routing path vector routing protocol is available. RIP is the implementation of distance vector routing protocol. OSPF is the link state implementation of link state routing, and BGP border gateway protocol is nothing but the path vector routing protocol. So in distance vector routing, the least cost route between any two nodes is the route with minimum distance. As the name implies that each node maintains a vector, otherwise called as a table, of minimum distance to every other node. The table at each node also guides the packet to the desired node by showing the next hop in the route. Distance vector routing table. This is the final table for the network having 5 nodes A, B, C, D and E. And this is the final table where each routing table contains 3 information to which node the cost or the distance will be. That is, A to A is 0. A to B, the least cost route is, that is, the minimum distance is 5. A to C, minimum distance is 2. A to D, minimum distance is 3. But A to E, there is no direct distance or direct neighbor for node E will not be the direct neighbor for A. So it can be sent through C. So what is the distance between A to E? Minimum distance through C, which will be 2 plus 4 is 6. But if we go through B, and the distance will be 5 plus 3, which is equal to 8 through B. So with C, the minimum distance will be 6. So we have the final table of through this algorithm. A's final table will be for A to E will be through C with the minimum distance 6. Similarly, the other routing tables for each other nodes will be calculated. The table for node A shows how we can reach any node from this node. For example, our least cost to reach node E is 6. The route passes through C. Now we have seen we follow 3 steps to find the least cost path between two nodes. First one is initialization, second one is sharing, and the third one is updating. Initialization, we assume that each node can send a message to immediate neighbors. Each node will send the message to immediate neighbors to find the distance between itself and these neighbors. Shows the initial table. This table, the tables for each nodes will be the initial table, and distance for any entry is not a neighbor is marked with infinity. That is, A to A is 0, A to B is 5 minimum distance, A to C is 2, A to D is 3, A to E there is no direct connection between A and E, so it will be going through C. So the E will not be the neighbor of A, so it is the distance from A to E is marked with infinity. Similarly for the other nodes, A to, that is B to A is 5, B to B is 0, B to C is 4, B to E is 3, but B to D is not the direct neighbor for B, so it will be going through the other nodes. So it is the distance between D to, that is B to D, will be given by infinity, and the same procedure will be followed for every other nodes. The routing table will be updated by means of this information. So each node will share its information with the neighbors about the distance. The second step is sharing. The whole idea of distance sector routing is the sharing of the information between the neighbors. Although node A does not know about node E, node C does. So node C shares its information about E to A. So the third column of the table will be updated by means of the sender name. The third step in the distance sector routing is updating. When a node receives a two-column table from a neighbor, it needs to update its routing table. Updating will be following three steps. You just go through it. It can be explained in a simple manner by having this diagram. And this is this initial table we have found in the very first step, initialization. Then we have shared the information. Then finally we are updating the information. Node A's table, final table, will be calculated by means of sharing the information message from C. That is, this is the old table, A is old table, that is A to A is 0, A to B is 5, A to C is 2, A to D is 3, A to E is infinite. That is, this is the A's old table. A's modified table will be calculated with the message received from C. That is C. C shares its information. So C, this is the information shared by C. So we are calculating A's modified table with A to, that is A to A through C will be 4. So A to C is 2, C to A is 2. So 2 plus 2 is 4. So A to C, that is A is equal to A to C will be 2. So this will be added with 2. So A to C is 4 through C. A to B through C is 2 plus 4, which is equal to 6. A to C is 2. A to D through C, there is no direct connection. There is no connection to D through C. So it is given as infinity. What is A to E through C? 2 plus 4, which is equal to 6. So this is the modified table. So we compare the A's old table with the A's modified table. We calculate A's new table. So where A's old table and A's modified table are compared, and the least cost route only taken. So when we compare A with the cost, here A with the cost 0 will be the least cost route, so that 0 will be taken. A to B, which is equal to 5, which is equal to 6, so A to B, that is this 5 will be taken, which is the least cost. A to C is 2, here it is 2, here it is also 2, so 2 will be taken out. And D, A to D is 3, A to D is here through C will be infinity, so 3 will be the least cost, so it is taken. A to E, which is equal to infinity, A to E, which is equal to 6 through C. So the least cost is 6, so 6 will be. Through C will be, it is updated. The third column is updated with the sender, that is through the C. So this is the final table for A's. Yeah, node A. Similarly, for all the other nodes will be calculated. B, C, D, and E. So that's all about the destination sector routing in this in this way. That is initialization, updating, and sharing of information. Each node's routing table will be calculated. Routing table will be telling how many nodes and the cost between each other nodes and the next cost route through which the information will be sent with the least cost. With this information we can have MCQs. A router is a device that mainly operates at which OSI layer. Routing table in a network in a router is used for, answer is network layer. Routing table in a router is used for making decisions about the route. An autonomous system is routing inside the autonomous system is otherwise called as, an autonomous system is a group of networks and routers under signal administration. Routing inside the autonomous system is intra-domain routing. Between the autonomous system is otherwise inter-domain routing. Which of the following protocol is an implementation of distance vector routing? For the link state routing, RIP is the distance vector routing, OSPF is the link state routing. And for the border gateway protocol, path vector routing. Distance vector routing, each node maintains vector. So vector. The distance vector routing, the process where nodes exchange information with neighbors is called vector of minimum distance to every node. Distance vector routing, process where nodes exchange information with the neighbors by means of sharing processes. A destination is not directly reachable. The distance in the routing table, how it will be updated with the value. During initialization, in distance vector routing, each node initialization. So directly not reachable given by infinity. Each node knows only its neighbor distance. So we have seen the distance vector routing algorithm, how to update routing table and find the final routing table for every nodes by means of three concepts: initialization, sharing, and updating of information of every other node. Thank you for your patience listening.